Okay, moving on to 9.5, solving cosine law problems. So for this kind of stuff, when they give you letters that you aren't familiar with, you can just swap them to be ABC. How long is t? Well, t is going to be little a. So how long is little a and how long is c? All we have to do is put the formula. So we know the formula from our formula sheet is a squared equals, did I write that? Where is that formula sheet? Attached at the back of your book. There it is. Equals b squared plus c squared minus 2bc cos A. And then angle C is just cos of C, A squared plus B squared minus C squared, all over 2AB. Good. That way it's just easier for you. So we have Jack, he's building a pool house in Lethbridge. He plans to place 60-inch solar panels on the side of the roof that faces south. This is the shown on the diagram. The angle of elevation has to be 49 degrees. What is the measure of the angle at the ridge C? So this one. What's the length of the other side of the roof? We got to know this guy first, so let's plug in the values. B squared is there, C is there. So 60 squared plus 72 squared minus 2 times 60 times 72 cos 49. We'll get 3115.6 blah blah blah. Square root it, and we get 55.8, 56 inches. That's this side. Now, what is the angle of elevation of side A? Well, the cos diagram, the elevation of side A is angle B. So what's angle B? That's the formula. Plug it in. We got 56, 72, 60, 56, 72. You get 0.58, inverse 0.58, and you'll get an angle of 54. So the angle of elevation is 54 degrees on that side. Awesome. Reflection, Jenna says that she could use the sine law to determine the angle of elevation for, is she correct? Explain. Well, we're going to get into the last section of this book, which is deciding when to use cosine and sine law, and you'll see. What is the measure of the angle at the ridge? That's number C. Well, 180 minus A and B is going to give you your answer. So 180 minus 49 and 54. We get 77. Good. 77 degrees. Okay. Example, we have Anik played a junior orienteering dog sled race in Yellowknife. The course is a triangle with the lengths shown. Anik's map needs to show the angles for the turns. What is each angle turn? So we need to know A, B, and S. We can call start, or C. So first one being cos angle A. We're going to put in the values. So our values are 5, 6.6, and 6. Plug and play. We get 33 over 66. 33 over 66 is about 60 degrees. And this is the exact same as 9.4, 9.5, the same kind of stuff, just more practice. What's the measurement of angle B? Well, plug and play again. We have the formula given to us. And we can just calculate 55, 79, and we get an angle of 46 degrees. What are the turn angles? The turn angles are 60 and 46. And that's on that little map right there. Okay, so those are all of the notes for this section. Now we'll do the practice. I'll go through the practice. We're given 16 feet here. This is angle R. QP 12, 12, 16. If you want, you can go B, C, A, 12, 12, 16. And this is exactly like the problem that we just did. These are equal sides, so that means angle B and angle A are going to be the same. What angle should the rafters meet? We have to figure out C. So cos C equals the formula. Oh, I should really rip that out. A squared plus B squared minus C squared over 2AB. So this is little a, little b, little c. Plug that all in and you're gonna get a degree. So that one's you. Sebastian, an artist in Vancouver, is making a wrought iron triangle for the base of an outdoor sculpture. The side lengths are shown to the left. What is the measure of angle A? Well, we have little a, little c, little b. Cos A equals b squared plus c squared minus a squared all over 2bc. That's your formula. Plug it in, those numbers, you'll get your degree. What's the measure of B? Same thing. Cos B equals a squared plus c squared minus b squared all over 2ac. Plug the values into here. Spits out. Remember to inverse cos. Cos inverse your decimals. And then get the degree after. And then angle C is just 180 minus angle A minus angle B. And you'll get your answer. All right, moving on to the last page of 9.5. Let's see what we have here. We have Jessica paddles her canoe 824 meters from the dock, and she paddles to shore. She turns the paddle to a picnic spot. How far is the picnic spot? So she wants to know how far P is from D. So that's little s. And again, I'm going to change these. So she wants little s, which we're going to call, this will be B. This will be C, so this will be little c, and this is going to be A. So we're looking for little c. Well, the formula for little c is c squared equals a squared plus b squared minus 2ab cos c, right? Cos c, yeah. That's your formula. Plug in these numbers. What's the measure of angle P, or that would be our B now because we changed it. I'll let you guys do that one completely on your own. I won't even give you the formula. See how you do. Should be able to figure that one out. And the last one here. Well, second last, 4. This map shows 2 routes of the corner of the Manhattan Avenue and Gateway, Elmwood High School. They meet at an angle of 79 degrees. How many meters shorter is the route through Chalmers Park than the route along the road? So we're looking for a little G, big G, E, M. I'll show you just a normal way to do it. G squared equals E squared plus M squared minus 2EM cos big G. That's the formula. Plug it in. Let's do it. 265 squared plus 175 squared minus 265, 175. Cos angle is 79. We get, after square rooting, we're going to get G is 288 meters. It's asking how many meters is it shorter? Well, we have to add these two and minus what we got. So 265 plus 175 minus what we got, our shortcut, is going to be 152 meters shorter. So instead of going all the way around on the streets, just cutting through the park is 152 meters shorter, and the distance is 288. And then the last one, we have how might someone use the cosine law when designing an outdoor adventure park with treetop walkways and zip lines? The walkways and zip lines might make triangles. A person who knows some side lengths and angles in a triangle could use the cosine law to calculate the length of walkways or zip lines or the angles for connecting them, then help build it better. Okay, so that's it. That was 9.5. Next video we'll be moving on to 9.6.